It will always remain amazing that in the search for the physical explanation of the universe, physicists were forced to the conclusion that consciousness is an ultimate reality. Ladies and gentlemen, quantum physicist Dr. Fred Alan Wolf.
Are we on? Can you hear me? Is there anybody out there? That's the question for tonight. Well, I'm very pleased to be back here in Portland. It's one of my favorite places to come to. I like the state of Oregon. Good place, good people. And I'm really pleased to see you all here. I'm really happy that you've chosen to come here instead of listen to Bill Cosby. Or other events that are going in town. So again, I want to say thank you very much. And I want to thank Terry Bristow and Nick Blosser of the Institute for Science, Engineering, and Public Policy. These are also very brave and pioneering souls. I think some of you should, if you have a chance, to find out more about their story and how they started and what they've done here. And I think it's a rather remarkable story of the kind of pioneering spirit that this state of Oregon has. And I think you all should be proud of that. So, enough praise for a while. I think there's some people still trying to find their seats, still coming in. That's a good sign. I like to see that. So, hold on to your hats. Hold on to your seats. Take a deep breath and relax as we're about to go into the world of God and the quantum. And as you know, it's going to be a multimedia presentation. I will be talking. I will not disappear from the stage. At least I hope I won't disappear from this stage. It all depends on what quantum physics predicts, and I'm not sure sometimes what it does predict. So, here we go. Stephen Hawking wrote a book called A Brief History of Time. Some of you know about the book. And what interested me most about the book was the end of the book. There he asks some fascinating questions, which I have decided that I'm going to try to answer tonight. Some of those questions go like this. Why does the universe go to all the bother of existing? And then he asks, is there a unified theory which is so compelling that it brings about the existence of the universe itself? And then he asks, or does this thing we call the universe need a creator? And if so, does she have any other effect on the universe? To be fair to Hawking, he said he. I'm saying she. Okay. And who created her, he asks. And then he continues. However, if we do discover something like a complete theory of this, then he says all of us shall be celebrating, our philosophers, scientists, ordinary people, all celebrating and taking part in this noble venture, in this noble discussion of this question of why it is that we and this thing called the universe even exists. And if we can find the answer to that, according to Stephen, then we will have what he considers to be the ultimate triumph of human reason. For then we would know the mind of God. Well, it's an interesting thought. I'd like to suggest that the universe, if it is ever discovered what those laws are, may not be as reasonable as we think it is. And maybe the use of rationality may be only part of the story of finding out what the universe is really all about. There may be another aspect to it, another component, something we might call the spiritual component or the sacred component. And we're going to investigate the sacred, the spiritual, and the scientific in tonight's talk. Then I'm telling you that. I'm just adding my ad libs in here to Hawking's questions. And then he goes on to say that we would, as I mentioned, we would know the mind of God. Well, now I would like to suggest something to you. We're done with Hawking now. Just suppose for the moment that each of you, through maybe an IBM ThinkPad or some other computer program, were able to suddenly you tuned into the mind of God. Let's just say that happened by accident. I don't know. And suppose that you had one chance, and you could either ask a question, which you may or may not get an answer, or you could tell God something and God would listen. She would listen to what you have to say. What would you say to God? Well, let's listen to the immortal words of Humphrey Bogart.
You've got to convince me that you know what this is all about, that you aren't just fiddling around hoping it'll all come out right in the end.
I couldn't have said it better. And so we're now faced with the question, but will it all come out right in the end, as Humphrey reminds us? Or are we convinced that God isn't just fiddling around with us? Well, for most of us, for a lot of us, maybe for all of us at times, we seem to be faced with problems in life. And like Job, we may at times feel that perhaps God is just playing a joke on us. Well, whether it's a Marx Brothers cartoon or the Vietnam War, we seem to be faced with the folly and the seriousness of existential life. And if we aren't concerned with such philosophical questions as to why we are here or who we are, then we certainly seem to be faced with real serious problems like population growth. Do you realize that within the next 6 to 7 years, we're going to have a population on the planet of over 10 billion people? I don't think we can think about our problems the same way as we did before. We need to have something like a new vision. We need to be facing our problems in a way that may be totally revolutionary to the old way. Doing business as usual, I don't think is going to work anymore. I think we really need to have some sort of new vision, and we need to look for guidance that each of us in our inner knowingness knows is the right thing to do. And I think we can find that. You agree with that? You can applaud. It's okay with me. I mean, I don't mind if you agree with me. Anyway, so, well, where is this new vision going to come from? Is this new vision going to come from, say, the world of science? Well, possibly. Is it going to come from the world of religion? Well, possibly. Or is it going to come from something between these two or something different than these two? I would like to suggest that this new vision has to be provided by a marriage between science and sacred. That we need to integrate the sacred into science and the scientific into the sacred in a way that's never been done before. I'm really suggesting possibly something new under the sun, which, as we may find out later on, is something very old under the sun that may go as far back as the ancient Egyptian culture. So I'm looking for something new, but something old at the same time. Well, we might ask ourselves, why do we have all these problems? So now we're going to start playing with these problems for a moment and see exactly what they are. Well, there's an old saying, I think you all remember the saying. It says, if you're in the middle of a storm, in the middle of an ocean or a lake, and it's really getting dark and it's stormy and you don't know what to do, it says, keep your faith in God, but keep on rowing to the shore. Maybe we need to find out what kind of oars we're going to pick up as we begin to investigate or begin to find out how we can solve some of our problems. So, what I'm going to do with you tonight, before we go into proposing any kinds of solutions to problems like that, or to consider the nature of whether God exists or doesn't exist, or the mind of God, maybe we should look at our share in this burden of existence. Maybe we should take into account a simple, very remarkable fact, maybe a scientific fact, maybe a fact which is beyond science. I'm not sure yet. I think it isn't, but some people may say it is. The simple, remarkable fact that each and every one of us here tonight knows that we are conscious. You know that you know you're a conscious being. I'd like to suggest to you that that very remarkable fact, that very central core of consciousness, is probably, in my mind, the most important link between the sacred and the scientific that exists. And I think we need to study that process as scientists, and I think we need to acknowledge the study of that scientific process as sacred beings. I think this is the bridge. I call it the bridge of consciousness, and what we're talking about right now is the investigation of conscious experience. So let's inquire into the nature of consciousness for just a few moments. Well, what is consciousness? I'll tell you, I just got back from a conference with a group of scientists. I was invited to present a paper on the quantum mechanics of dreams, which 20 years ago would have been considered totally, in left field, off the wall. But now science is beginning to recognize, maybe dimly, but still beginning to recognize that consciousness is something that needs to be studied, needs to be looked at, and one shouldn't just throw one's hands up in the air and say, oh, I can't understand consciousness at all, that it is possible that we might find a way to deal with it in some way that helps us understand ourselves even better. So let's begin by asking some simple questions. Is consciousness a byproduct of our material bodies? Well, we've been thinking about this question for a long time. What is consciousness? Certainly, as far as our human experience tells us, without going to gurus or going to people that have had extraordinary experiences, we seem to think that at least we need a body to have consciousness. At least we don't seem to be able to detect anything like consciousness without a body. However, there may be another possibility. Is consciousness somehow something that is given by God, a God-given process, and that we are literally spirits, as the song goes, spirits living in a material world? Well, the answer may seem to have been solved by scientists, that we are not spirits, according to some scientific views, and in fact, as far as their points of view are concerned, that there's no room at all in the world of physical or scientific investigation for anything like God or a spirit. But I'd like to suggest to you that that type of thinking, that type of reasoning is based upon a fallacious picture of the universe. It's based upon a classical Newtonian mechanical picture of the universe, and it doesn't take into consideration this thing, this new thing, this thing we call quantum physics. And quantum physics is frankly very weird. And because it's weird, and I'm going to try to share some of its weirdness with you in, I hope, surprising and interesting ways, it leads into some new possibilities, some new ways of thinking. For example, quantum physicists do not deal with the material world. You may think, what? Scientists have to deal with the material world. No, they can't make a prediction worth one iota about the material world. What they can predict is the probabilities of a material world. We can predict with absolute certainty, we, meaning we quantum physicists, or we scientists engaged in using the tools or following the quantum rules, that we are able to compute with absolute certainty the probability of anything. And we have a vision when we do this. We have a vision of these probabilities, and these probabilities are not just odds on on some back of an envelope or odds listed in a crap table's rule manual. They are actually envisioned to exist as something moving in space and time. That these are probabilities, we call them possibilities or probability amplitudes. We have different languages to describe it. We see it as something which actually moves or vibrates in space and time. And it's this new vision that I would like to share with you tonight, because I think it's a very exciting vision, and I think it's indicative, and this is one of my major points to you, it's indicative of some aspect of spirit. That spirit is reflected through these possibilities that we have. In a certain sense, God is providing for us possibilities, and if we're smart enough, if we have enough heart, we can see them, and if we're not, we don't. And it's just a simple matter of that, being able to have enough heart to see them. So, what about science? Can science lead the way? Well, you know what's remarkable about science is that science is a kind of a double-edged activity. There are only a very few creative scientists. Oh, yeah, there are scientists that are very good at doing certain kinds of things, and they may be very ingenious at finding a way to repeat an experiment or do an experiment again in a way that's slightly different. There's a lot of creativity, but in terms of the real, groundbreaking ideas in science, there's only been a few, and it's rather remarkable that so few really breathtaking, groundbreaking ideas appear in science. Why aren't there more? And some people wonder about that until you realize the reaction that scientists have to new ideas. It's kind of like growing up in a scientific family, or when you go into the scientific world, it's kind of like growing up with parents that are very severely critical of every action you take. And so after a while, you begin and you learn not to ask certain kinds of questions. In fact, even in quantum physics, we tell people when we're severely disciplining them when they ask dumb questions, we say, don't ask such a question. There's even an interpretation of quantum mechanics which says, thou shalt not ask about what you cannot observe, all man. You know, I'm serious. We have religious rituals in quantum physics which tell students, don't ask. You can't talk about that. We have so many prejudices, so many real dogmatic attitudes that in a certain sense science has become more of a religion than religion has. And it's time to break that. Do you understand what I'm getting at? Yeah, thank you. I'm really a great audience. I really believe that that one of the problems with science education today is simply that students find it very boring not being creative. Well, right. And what we need to do is to encourage all of us to be creative about anything we do in our lives. And I think this is very much a part of our spiritual heritage, of our sacred heritage, is to encourage our creativity, to encourage our minds to see things in new ways, not to discourage them at all. It doesn't mean we can't be critical of ideas. We can offer criticism, but the criticism has to always be offered in a loving way. It cannot be offered in a harmful way. And that's part of the problem. A lot of we scientists have been raised with harmful attitudes. If we dare question a professor about some problem that we are faced with, we're often found to be chastised or put down, or even worse, given a non-passing grade by being argumentative. So I think it's time to encourage creativity in science. So, well, let's talk a little bit about one of the most creative elements, one of the most creative ideas, which is the nature of quantum physics, and see how we, as quantum physicists, have got into trouble with attempting to see the world through Newtonian mechanical eyes, through the so-called rational picture. What basically happens in science is that we have a certain way of proceeding which says, look at things in the small. If you've got something big, you've got something complicated, break it down into smaller parts, and if we can understand how the little things are behaving, then we're capable of understanding how the big things are behaving. So, that's what we did. We were very clever at inventing instruments which allowed us to probe into smaller and smaller spaces of space and time. So we began to find things called molecules. And as we probed deeper into this space, we began to find that molecules were made of things called atoms. And as we probed even deeper into smaller and smaller spaces, we found that atoms contained within them subatomic particles, and one of them was called an electron. The electron is probably the most ubiquitous, the most amazing, the most fantastic particle of matter in the universe. It's totally stable. It carries an electronic charge. It has a little bit of mass, and it doesn't seem to exist all of the time. The most amazing thing about electrons is that there isn't a single human being anywhere at any time that's ever seen one. Think about that a moment. We certainly believe they exist. We've observed electrical currents. We've even have observed a charge to mass ratio of an electron, but we've never really ever seen one. We've never really captured one as we might capture, say, a baseball or something like that. We certainly have never seen them inside of atoms, but we infer that they're there, and we have pictures based upon those concepts. Well, even though we've never seen one, and even though electrons are weird and seem to disappear and reappear from time to time inside of atoms, even though electrons and atoms can undergo things called quantum jumps, and a little later in the presentation I'm going to take you on a quantum jump of your own, even though these things happen, we've been able through quantum science, through the rules of quantum physics, to be able to build and create devices of all kinds. For example, this IBM ThinkPad computer is inconceivable without quantum physics. There's no way that you can build a chip to run the way this little microchip does, which governs the main processor of this computer, without an understanding of quantum physics. So, all modern computers are based upon quantum physics. So are, most of you don't realize, or maybe you do, that your automobile has a computer in it if it's a later model. And so the computer is in many of the gadgets that you're working with today. Even if you've never bought a computer in your life or plan to work with one that you type on, you're probably using one in one way or another. Quantum physics helps us to understand the way lasers work. It helps us to understand how we can use lasers in medical technology. It helps us to understand things about magnetic resonance, how we can use magnetic fields in order to look inside of human bodies in a non-evasive way, possibly a non-evasive way. There's still some possible debate about what magnetic resonance and magnetic fields are doing to our bodies. Maybe they do evade in some way, but most people feel it's a pretty safe technique. Quantum physics is helping us to understand new ways of envisioning new creative worlds, new creative elements that are coming into our world. There's presently at foot a whole new technology which has been called, quote-unquote, cold fusion, which is an energy source coming out of water, possibly itself. And nobody's caught a model of it yet. This is a very encouraging sign. We're seeing experimental data, we're seeing things that are very encouraging, saying there's energy coming out, but nobody's figured out a model of how it's working. So I'd like to encourage the young scientists out there that are brave enough to risk being wrong to come up with a creative model. See if you can figure out how some of the energy sources are coming out. There are a number of scientists that are working in that field, and quantum physics, I think, is at the foreground of that as well. So, now that we've looked at just a little bit of quantum physics, I think it's important for us to understand, since I'm going to be attempting to build a bridge between science and spirituality, I think it's probably necessary that we understand how, in the first place, did Western science and religion, or spirituality, or the sacred, divide. Well, in the beginning of our rational thinking, in our Western rational thinking, which I would date back to the time of the Greeks, we are already beginning to sense that the sacred or the spiritual and the scientific or the material, and I'm putting in equal oars here, should be separated. It really begins, I would say, with Aristotle. Aristotle said everything is made of four essences: earth, water, air, and fire. These were the four essences. And the reason the way the world works, the reason things move, is because they're attempting to find their natural place in the world. And since most things are made of these four elements, and since they're composed of these four elements, then the thing itself may be in a place which is right for one of the elements, but not right for the other two or three. So that would mean that it somehow has to be, it would seek some way of finding its rightful place. The rightful place of these elements was for the following. Fire, for example, would go up into the stars. Okay? Air would literally go out the window. Water would dissolve or evaporate, go into clouds, and the earth would go below. So in other words, these were the basis of the four elements, and they're natural places of the universe. But there was a fifth element, something we call the quintessence. This quintessence, or fifth element, was called physis, from which we get the word physics. It's interesting that the Greeks used the word physis to represent spirit. So what Aristotle was doing in this classification scheme was separating spirit from matter. Spirit was that which animated matter, and that which animated matter from a cosmic point of view. Physis was not an element contained in these other four. So here we have, if you will, the beginning of what we might call the mind-body problem, or the mind-body split, or the beginning of the nature of the separation or division of spirit and matter. Okay, well, we need to go back a little further in time to find out how we saw how the root of science in Greek, in Western Greek thinking, started to cause a cleavage. We need to go back even further to find out how our Judeo-Christian heritage, our spiritual heritage, started to form this cleavage. And it probably begins with the notion of God that appears in the Judeo-Christian heritage. Before there was a male God, a wrathful male God, there was a period of time that gods were goddesses. They were feminine. And this was maybe the time of Gaia, or the time of a different form of a spiritual belief. And that was an earlier time, and somehow we lost trust with that time, and we began to paint a picture which indicated that God was no longer a she, that God was becoming a he, and was a wrathful male God. It's a very important kind of picture, because this couples into the Greek notion as well. You see, what's happening here is that the male God is considered to be something up above us all and wrathful, and the female goddess is considered to be down below in matter and part of nature and not to be trusted. So nature becomes a she, and the spirit becomes a he. You see where I'm getting at? This kind of division is taking place in Western Judeo-Christian culture. And in the Greek culture, which is also a very masculinized culture, we're also beginning to see the vanishing of the feminine spirit. She is of lesser importance to the Greek culture, and we're beginning to see an over-masculinization. We're becoming over-left-brain rational. In fact, the Greeks' basis of their thinking is that the universe should be figured out rationally. Now, that spirit of the Greeks, that the universe should be figured out rationally, is very much a part of the modern university today. The modern university basically teaches us that everything should be figured out rationally. What I'd like to suggest to you is that you can't do that. I want you to hear that again. I'd like to suggest to you that it's not possible to figure out everything rationally, that there is definitely an irrational component to the way the universe works, and that this irrational or this sacred component is something that you can sense without figuring out rationally. It's not necessarily going to be logical, and yet you will have maybe a very profound experience that isn't logical. Jung was hinting at this in terms of synchronicity. In our present culture, we divide males and females, and we place males in the rational camp and females in the irrational camp. We say that males think logically and get cause and effect, and females don't think logically. Of course, that's nonsense, but we have this basic picture in our minds that we're somehow divided, okay? But even if we take that picture to heart, then we're looking at what I might say, with that picture, a need to feminize the culture, to bring this other aspect, this other part of life, what I consider to be the sacred part of life back into our culture again, back into our way of seeing, so that we have intuitive, sacred grasps of what's happening, rather than purely mechanical, logical grasps of what's happening. I think this is a very important lesson for us. With Moses going up to Mount Sinai, we have another lesson which sort of adds to this picture. Moses goes up, you might say, feminized, listening to the voice of God, maybe in a spiritual place. Moses comes down, you might say, masculinized. There's the joke. Moses is coming down with 3 tablets, and he says, I've just spoken to God, and he's given me 10 commandments to... I think it was Mel Brooks that made a movie like that once. I kind of like that. That here we're having what you might call a kind of a nervous breakdown. Julian Jaynes calls it the breakdown of the bicameral mind that Moses may typify for us. Certainly it may be typified by Homer in the period between the Iliad and the Odyssey. So that now we need to make up rules to govern our behavior. And it's very interesting that the 10 Commandments, of the 10, only 3 say do this, and 7 say don't do that. No. Well, from these roots of the masculinized, over-rationalized, logical sense of the Greeks, and the appearance and the moving down or the pushing out of the feminine by the Judeo-Christian concept of a male god, we're beginning to see how our culture gets into the problems we're in right now. As we go through the Middle Ages, it doesn't get any better. Mysticism is cropping in, certainly. You can't keep... It's like to try to suppress the feminine in us is like trying to suppress half of your psyche and body from functioning. It just doesn't work. It's going to emerge. Jung would call it the shadow is coming out or something like that. But you can't suppress yourself. It's like the right hand saying, I'm no longer going to use the left hand anymore, or the left hand saying, I'm no longer going to use the right hand anymore. It's just an impossible thing to do. So it comes up. But there's still a sense of wanting to keep a sort of kind of spiritual order, a religious order, the order of the Christian church, which is tending to suppress and hide knowledge by putting it into monasteries so that nobody knows what's going on. Then we have the Middle Ages coming out, and then we have a few people who are brave enough to counter the church. And now we run into, this is probably the root of why science mistrusts spiritual concerns. It probably stems right here. It probably started maybe with King Henry VIII, who tried to separate church from state because he wanted to marry more than one wife. It probably starts there, but it also is. It's also seen again in the case of Galileo, where the church is prosecuting Galileo for his ideas, and he has to recant, saying it's only an idea that the Earth is not the center of the universe. It's an equivalent way of thinking that. We see that happening today. It's going on today, only this time the church has become a certain element of science more than it has the old church of Christianity. So it's science, it's become like the church of today. You can't suggest things, even like cold fusion, when it was first brought out, most of the universities did very poor experiments to verify it, and when it didn't work, they really shot down anybody working on it. They literally, the 2 scientists who discovered it were virtually kicked out of the country to do any research. It's only this is sad. I mean, America, wake up. This is very sad. It's a very sad situation that we have to punish our creative people. And think about that a moment. So, with through the Middle Ages, and with one probably remarkable philosopher whose name is René Descartes, we have a remarkable thing that happens to him in a snowstorm in Bavaria. As Oliver's computer tells him, I think, therefore I am. By the way, how many of you watch Star Trek The Next Generation? Do I got some fans out there? Do you remember the one where Dr. Moriarty decides to leave the holodeck and walk into the spaceship? And then they figure out that that Moriarty has created a simulation of the whole spaceship. And so they decide to work with the simulation that he's created of the whole spaceship and make a simulation of the whole universe. So eventually Moriarty ends up as an imaginal realm figure within inside of a little cube. And so while Picard and Riker and everybody are looking at this cube saying, do you think he knows that he's only a creature of our imagination, this little cube? And meanwhile, in the little cube, we see Moriarty and his sweetheart bubbling off through space saying, whoa, far out, man, we're free. I think, therefore I am. Whoa, I thought myself in existence and now I am. And they're bubbling off. And meanwhile, Picard and Riker say, we could shut this thing down. Just turn off the switch and he's gone, And then Picard turns to the audience sort of and says, how do we know that we're not in somebody else's cube? I would like to suggest to you that we take that seriously. We're going to come back to that theme a little later. It gets wilder, folks. Well, the real father of the mechanical universe, the picture of the hyper-rationalistic universe, is, of course, Isaac Newton. What's ironic about him is that he's a mystic. He's a bit of a crazy, and in terms of the rational mind. And most of his time wasn't spent in rational mechanics. I think he was the head of the Mint, some kind of job that he had. And he was really interested in Kabbalah. And how does God do it? I mean, basically, that was his main concern. So Newtonian mechanics, of which we now use to launch rockets into space and drive our automobiles down the street and do everything from play football to shoot hockey pucks or whatever we do, basically was really a kind of a sidelight to him, something he did in his spare time while people were dying of the Black Plague. Interesting, when you think about the time of Isaac Newton. Isaac Newton's crowning glory is, of course, the discovery of gravity. And the notion of orbital motion of planets about other planets, like the moon about the Earth, or the Earth about the sun, or about a blue star. I fudged a little bit there on the computer program. Those of you that say, wait a minute, that doesn't look like Newtonian mechanics to me. Yes, I know it isn't. I just like to see if you're awake. Okay, anyway. Newtonian mechanics is a way of seeing, and it's a very successful way of seeing. Most of us don't realize that the Newtonian picture of the universe had an enormous influence on a whole wide range of topics which are of vital human concern. For example, it influenced the law. It still does. There are now experts, scientific experts, who are brought into traffic cases to analyze the motion of automobiles to decide whether or not a particular accident happened the way people described it. Okay? A small example. It influenced politics. Karl Marx was very influenced by the Newtonian picture and the whole notion of dialectical materialism, or the movement of one force against another force. The idea of forces in general was fundamentally an action and reaction picture that he had based upon Newtonian dynamics. Sigmund Freud, model of the psyche, and the model of the libido was based upon a conservation of energy, of mechanical energy. He very much thought of things in terms of mechanics. And not least in all this is also Clarence Darrow defending the two young murderers, Leopold and Loeb, who thought they were kind of super beings for murdering a child in Chicago in the 1920s. He defended them and saved their lives. In fact, one of them was released about 15, 20 years ago. The other one died in prison. Saved their lives. They would have been given the death penalty had he not convinced the jury that these two criminals were as much victims of the law of cause and effect, or mechanical action, as the child that they murdered. Very interesting that Newtonian mechanics actually had that effect. Well, as we began to use the tools of Newtonian mechanics to explore deeper into nature by going into smaller and smaller regions, we found something called the new physics. And so what we need to consider next is just what is new about the new physics. Well, if I were to bring out what I would call a father-mother figure of the new physics, I think I would have to point to Niels Bohr as the one who most represented the major jump in our thinking, the one who saw that the Newtonian picture could not really totally apply to our understanding of atoms and molecules and energy and things of that sort. What Bohr was sensing, what he was beginning to see, was that there was something irrational in the behavior of subatomic matter, something which did not fit the picture of a perfectly continuous classical mechanical action. When he composed his model called the Bohr model of the atom, he had a vision of what the atom looked like, and the atom was to him something like a planetary motion, very much like a Newtonian model, a nucleus at the center, which is like our sun, an electron moving in a circle or an elliptical orbit about the sun, and we more or less saw that the electron was a particle, like this little white square that you see moving around, and that electron, of course moving much faster than I'm moving it, would be whirling around in an orbit like so. Okay? So what we're going to do now is we're going to look at what he predicted would happen. What he predicted is that every once in a while this electron was moving around in the orbit like so, it would stop doing that and it would just jump suddenly to another orbit, just like that. So let me show you that picture. This is about to take the quantum leap, and boop, it's made the quantum leap. The white square tells you where it was. The green circle tells you the orbit it finally ended up in. Well, what's very interesting about that is that it was a quantum leap, a jump from one to the other without going in between. It was very disruptive to any kind of rational thinking, and it also led to a question, which was very subtle, that wasn't asked, because to ask this question would be too much. The question was this: Bohr could calculate the different orbits, and there were actually different orbits of different sizes. There were orbits of, let's say, 1 unit, 4 units, 9 units in diameter, okay? But there was no orbits of 7 units or 8 units or 3 units in diameter, okay? They went 1, 4, 9, 16. They went like the square of a number. And if the electron was in one of those orbits whirling around, and it decided to jump to a lower orbit and then start whirling around, in which it then gave off light or radiation, people said, well, that's weird, but nobody asked this question. How does it know which orbit to jump to? How does it know whether it should go from 16 to 9 or from 16 to 4? Well, how does it know which of the lower orbits it should jump to? Does it look into the future? Well, I'm going to suggest to you a little later on, from a quantum physical point of view, that indeed this is a possibility which we must now take more seriously than we ever had before. Just to give you another handle on this quantum jumping, forget the orbits for a moment. This is sort of what I envision a quantum jumping electron to look like. You can see this black dot right here. I have this magenta colored circle here representing a nucleus, and this sort of cloud of yellow represents a cloud of possibilities. Watch what happens. That's a quantum leap, more or less. It jumps from what is to what could be without going in between. Now, what was later discovered was that somehow we, as observers of atomic phenomenon, were involved in this process. We didn't quite see it when Bohr came out with his model, but later on, as we got deeper into it, we began to see that particularly Heisenberg, who developed this idea in the 20s, began to see that somehow it was us, we who were the ones who were causing the leaping to take place in the first place. Which meant, in a very strange way, that somehow our acts of observation, the ways we chose to look at subatomic phenomena, we're acting in the universe. Well, this might suggest to us that the universe and we, remember Hawking's creation, how do we come into existence in the first place, that we and the universe might be somehow joined together in some way, that the separation into an observer and observed may be some kind of, let's say, approximation, let's say an error, let's say a kind of dream, let's say a process in which there's an inevitable effect, in which there is a kind of a blurring or an uncertainty which arises. In other words, in breaking what David Bohm calls the unbroken whole, we are seeing uncertainty and doubt creep into our consciousness. Which means if we don't do that, if we don't question, if we don't observe, so to speak, if we stay within the framework of maybe some kind of meditative state, we become part of the whole, as shown in this Escher drawing. Here we see an observer in an art gallery looking at a painting of a city. And as we explore the city and move along the frontiers of the city, we see there are buildings in it. It's all within the framework of the painting, until we notice that the painting is actually extending outside of the city is actually extending outside of the painting. And at the roof of this particular scene right here is actually the same roof of the art gallery, and that these pillars are really not pillars of the painting, but pillars of the art gallery, and that this observer is actually part of the painting that he's observing. We have a kind of a self-referential loop here, which is implied by the Escher drawing. I believe that this self-referential loop is a key or a clue to how consciousness arises, and that when we don't break the whole, we have a sense maybe of self arising in a certain kind of way. And I'm going to try to share that with you as we kind of go on. Well, this means that the observer in quantum physics, by breaking the whole, by observing, is doing something very, 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 very different from an observer in so-called classical physics. So I think the first thing we need to do is to look at what we might call the distinction between observers in the old and the new physics. Now, what happened to my program here? This should have snapped on much quicker than that. Oh, wait a minute, no, excuse me. Missed my point here, missed my cues. See, this whole thing, by the way, is cued. And I know exactly when to pause to wait for the machine and when to continue and so forth. I missed my cue, forgive me. Okay, but anyway, I've recovered enough. So what is it? You see, I have to serve the machine. The machine does not serve me, I must serve it. I'm worried about this, folks. Multimedia, virtual reality may be the end of us all. I'm not sure. Anyway, what is the distinction between observers in these two forms of inquiry? Well, in the old physics, the universe is assumed to exist. God knows how it got there. Notice how you did a double take on that one? You're getting there. You're in You're entering quantum reality with me. Very good. You're getting it. Yes, that's the way, you know. That can be taken two ways, of course, and it was intended to be taken two ways. And if you can hold both ways in your mind at the same time, you've just entered quantum land. Very good. Okay. Yes, it can be fun. All right. The universe was assumed to be out there, independent of us. And somehow we came along and we looked under the rocks and we looked out into space and we looked down at the things, and we might have disturbed things a little bit, but in our sense, we felt that our presence was not affecting what was out there. That was the old way. The idea was to observe, record what you observe, write down on your writing pad mathematical laws, and let it go. Okay? But in the new physics, we don't deal with that. We actually have to deal with possibilities. We can't deal with actualities because we have no way to really calculate them. So we have to look at all the various possibilities. Instead of being able to say that what I write down on my little writing pad is a description of what's happening in nature, I say that what I'm writing down on my writing pad is a description of what I can possibly observe about nature, and those possibilities depend on what I choose to observe about nature rather than what is absolutely out there in nature. In other words, we see that what we see depends on how we choose to look at what we see. And the two basic pictures that have arisen in what we might call the old version of quantum physics, the one that's probably the most popular in the lay literature, and I may be responsible for making it popular, I don't know, is the so-called wave-particle duality. That particles, objects, quantum objects, subatomic particles, or whatever they are, can exist in two guises, in a wave guise or a particle guise. So let me show you a little picture of that. In an experiment, we're going to look at quantum waves of possibility starting at a source. The source represents an event of awareness of an object in space. And then, the next moment of time, we're not looking anymore. And now we're looking, the picture I'm going to be showing you, I want you to look, the picture I'll be showing you is how we think this object behaves as time goes on. It kind of spreads, not necessarily in those three stages, but it just spreads out like a wave in a pond, okay? These are quantum waves. And this sort of like pattern that we see, or this ellipse or circle, depending on how it's drawn, represents the state of our knowledge about where the object might be. Remember, it starts out here in the center, and then where does it go next? Well, we don't know. All we know is it's possibly any place along this edge. And now we must have an action taking place in the universe. So far, everything's unobserved at this point, and then the observer steps in. And like a magician waving a wand, a particle appears. This is the basic idea of the wave-particle duality, that when we're not looking, it behaves like waves. When we do look, it behaves like particles. So the not looking aspect of it implies some kind of letting it be, and the looking aspect implies some kind of disturbance that we get into. So in the new physics, we have the notion that the observer becomes part of the observed, and that in observing disturbs the observed in some fundamental way. Now I'd like to do, if I may, a little experiment with you. I would like you to pretend for a moment that you are either quantum physicists, or if you want to, you can pretend you're shamans. Because what I'm going to do right now borders a little bit on something we might even call magic. I'm going to have you look at an object in space, and I'm going to have you describe in words to yourself and to all of us in the audience. You have to be willing to play with me. I hope you're willing to play with me, and say what the object is. Then I'm going to do something. I'm going to do a kind of I'm going to give you some certain words. When you hear those words, you'll know what to do. And as a result of that, by simply looking at this object in another way, which you'll know how to do, you will make the object completely disappear before your eyes. Would you like to do that? Okay, it's like a magic trick. Okay, are you ready for this? Okay. Now, before I show this to you, I'd like to suggest to you what this represents. Okay? That when you first see the object, I want to say that this is an act of disturbance. This is the act of the observer. This is you looking for a particle. This is the metaphor, a visual metaphor of you looking for a particle. Okay? So, are you ready? Hold on to your eyeballs, because here it goes. What is that? Good, a cube. Okay? Now, I want to ask you a question about this cube, which I will typify or explain to you by using the little white square that I put up. You see this strut of the cube? And here's another strut. And here's another strut. And here's another strut. Okay, that represents a face of the cube, a square face of the cube. Okay. And now here's another one. Another face I'm going to outline. This strut, and then this strut, and then that one. And this one, that's another face of the cube. Let's call the one I'm outlining right now the upper face of the cube. And let's call this one I'm outlining right now the lower face of the cube, okay? Now, I'd like you to answer this question. Some of you already know what's coming. Which face is in front, the upper or the lower? Now, for how many out there see it jumping? Ah, good. I knew I was in the right place. For those of you that don't see it jumping, be patient with yourself. It will leap for you. This is an analogy of a quantum leap, a particle-to-particle event. A jump, a jump, a jump, a jump. How many of you see this thing jumping so much that you can't hold it still? Ah, yes, I know I'm in the right place. Very good. Okay, now, this is equivalent to looking at the world in terms of particles. They're uncontrollable, they leap, and in fact, let me milk this analogy even further. If I ask you to look at this rationally and tell me where the jump is taking place, I would imagine most of you would point to your heads and figure out it must be in your brains. But if I ask you to look at it irrationally, without thinking about what it means or trying to figure it out, but really just point to where your experience of the jumping cube is taking place, then you might point to the screen and say, it's jumping out there. Right? So what your experience is telling you and what your logical mind are telling you are two different things, aren't they? Interesting dichotomy, isn't it? That we can be in such a position where our book learning or our school, our educational process, and our experience are in such differences that in a certain sense we have to lie to one to get to the other. We're faced with that. This is part of the dilemma that we're finding in teaching. This is part of the dilemma of why we're losing students. We lose them when we tell them that their experience doesn't count in the world. It's what we teach you that counts in the world. Are you with me on this? So, now I promised you something, and I would like to fulfill that promise. What I'd like you to do right now is I would like you to look at this object in a different way. Now watch what happens when you do. I'd like you to notice that there is a blue square here. You see this blue square? Concentrate on that as a blue square. Look at this piece here as a blue trapezoidal piece. You see it as a blue like a kind of a blue geometrical piece? Here's a blue triangle, another blue trapezoidal kind of piece. Look at these blue pieces as if they are pasted on a red background. Okay, in case you're having trouble with that, and if you're still having trouble with that, watch. Blue pieces pasted on a red background. Or a cube. Depends on you. I've simply augmented your experience. The best part of this is when you see it this way without me going into any computer graphic changes for you to see it. When you see it as blue pieces on a red background, this is what I would call akin to the wave, the momentum, the feeling, the intuitive, the feminine aspect. There's no jumping, it's calm. It's sort of like a metaphor for maybe the spiritual aspect. When we're seeing it as a cube, jumping, agitated, moving, it's sort of the logical, the rational, the thinking, more the masculine in that sense, if I may use that metaphor. I don't necessarily like all the ways I'm using this metaphor, mind you. I'm just using it in terms of our present terminology as suggestions of how our thinking processes might work in this case. So, what we're seeing here, basically, is that the two ways of seeing are complementary to each other, and that this is illustrating something called the principle of complementarity. And so, it may be that this visual analogy is more than just a visual analogy. It may be that somewhere in our brains, processes like these are going on. And that if we become fixated, let me say the word drug-stoned on rational thinking. I mean stoned. I mean really, so fixated on rational thinking that all we see are cubes jumping, and therefore life seems to be very uncertain. Things seem to be beyond our control, etc. If we go into maybe the quieter state of blue pieces on a red background analogy, where things are just calm and there, and we see the glowing aura of presence, akin to maybe spiritual presence, maybe we can learn to do that with everything that we witness in the world. In other words, even looking at each other, maybe we can begin to stop looking at each other as cubes and begin to see each other as glowing auras about ourselves. I'm convinced that we can do this. I'm convinced that it's our heritage to do it. I'm convinced that we need to ignite this sacred function in the ways we deal with each other, not just on Sundays, but every single moment, every single second, every single nanosecond, every single nanosecond of our lives. Thank you. You're a great audience. I want to applaud you. I mean, wow. I mean, this is very, I'm heartened to hear the response that you're giving me in this, because I feel this is so important, and I'm so pleased that we are sharing this as one mind in this. And maybe you may have disagreements with me, and I would encourage you to ask me questions if you do, or to bring up other points that may be more enlightening than I'm bringing out. But I certainly feel very encouraged by your warm response to me. So, shall we carry a little further on? You want to go more? Okay, great. Okay, good. Let's look even deeper. Let's go into the nature of matter in the new physics. What does it mean to have a material universe? What is matter really composed of? I mean, how is it behave? Well, looking at matter in the universe is like looking at matter as a Mad Hatter. It's an Alice in Wonderland world. As we start to probe the atomic and subatomic world, it's like being invited by elves to an elf house. And every time we peer into the elf house or knock on one of the elf house doors, the house is shaking so badly as it meanders back and forth that we realize that in order for us to really see the elf house, we've got to catch hold of it in some way. But every time we try to grab it, we knock it about even worse. It's sort of like trying to make the cube stand still. So that we have to later just sit back a while and realize that it's our pictures of the universe which are telling us how to go about grabbing it. If we see it as an elf house, we may try to hold it down a certain way. If we see it another way, we may try to look at it a different way. In other words, there are literally many ways of seeing or looking into not only the subatomic realm, but I'm suggesting as a metaphor, mind you, that there are many ways of looking at or seeing into our human nature. The scientific maybe, the rational maybe, also the spiritual or the sacred maybe, and that we need to reignite this other way of seeing. And I'm saying it isn't that difficult, because you intuitively know what it is as soon as you begin to recognize that you have a consciousness and the ability to know that you know. So, if you ask me what is the physical world actually made of, I would say it depends. It depends on how we go about looking. One picture is to imagine that underlying the physical world is another kind of maybe a mystical space. I hate to get too hand-wavy with this, but I'm trying to provide a visual metaphor for you. David Bohm calls this the implicate order. Henri Corbin, a French student and writer dealing with Eastern spiritual practices, calls it the imaginal realm. I like the imaginal realm. I also like Bohm's implicate order. I worked with David Bohm for several years when I was a research fellow at the University of London, and I really had a great fond love of this man. He was he died last year. He was very brilliant, and I think had a great spiritual concern for our planet. That in Bohm's view, or in Henri Corbin's view, or the nature of the implicate order, that there is an order out there which includes us, but doesn't look anything at all like us or the usual things that we look at when we say we're looking at the universe. It's kind of like waves in a pond that ripple in the pond. And that matter appears as kind of in air. Looking at when these bubbles in the pond occur, we're looking at matter, and we're referring to it, if I may, as trapped spirit. That what we're looking at is that matter is a sacrifice of spirit. Matter is, you might say, a sacrifice of God. Or you might say, God so loved the world that she gave her only begotten daughter. Do you follow what I'm getting at? That the spirit is embedded into the material world. Or God gave his only begotten son. I'm bending Christianity a little bit, but forgive me, I don't mean anything anti any religion in this. I'm just opening up the possibility here by expanding the vision of what we mean. In other words, what I'm trying to suggest here is that the sacrifice of spirit into matter is, and the formation of matter, that matter is unconscious spirit. And that's basically what has to happen in order to have a material world. There has to be a willingness to go unconscious. So what would matter be in this new way of seeing? I would say that matter could be thought of as not always existing, because nobody wants to remain unconscious too long, including matter. So every once in a while, matter pops, goes back into the spiritual realm and says, "Woo, I'm free!" And then a whop, it collapses back into matter again, so that it does what it's supposed to do. It makes its sacrifice. It's sort of a life-death, birth-death, birth-death. It's an ongoing dance. It's happening at such an incessantly rapid rate that it's almost beyond our capability to even see it. At the quantum level, at the vacuum of space of level, it's happening maybe on a scale of 10 to the minus 43 seconds. It's quantum foamy. It's the continual dance of life and death, even at that level. And all life and death is, from this perspective, is going from conscious free spirit into unconscious matter, and then back out again. And I would like to suggest that that's what we are too. That we are trapped spirits momentarily for this nanosecond that we call our 410, that we call our life experience. Well, if we're in that kind of a cosmic crap game, then the best we can do is figure out the odds, because we can't know for sure that we're going to be here all the time. So we're dealing then with possibilities. Quantum physics simply is the way of dealing with these possibilities. It's sort of a new vision. So in this world of possibilities, we're dealing with something also new. And this is a new idea. I haven't shared this idea with you yet before. And it's one that's a little difficult sometimes to grasp. I've tried and thought, what kind of visual analogy can I make to make this idea clear? I'll suggest one to you, but it's not as convincing as I would like it to be. And although I understand it myself, I find this one of the most difficult concepts to really explain clearly. It's the notion that possibilities, two or more of them, can come together and produce a third possibility which doesn't look anything like the two possibilities that had come together. I think the closest I can come to the analogy of that is a child compared to the father and mother. We know that children have the same DNA codes as the fathers and mothers, and yet the child's behavior is not at all necessarily like the father and mother, even though it may resemble it in some ways. Maybe this visual analogy might work. This is about the best I could think of in the time that I had to prepare this. I'm not sure it's the best one that I could ever think of. The reflections of a plane, where we suddenly see two possible reflections blending together to produce a two-ness coming out of a oneness, so that the two points you see here, the two focal points here, are not in the original plane that this is reflecting. This might give you the idea of the addition of two possibilities overlapping into one. The notion of wave particle is another aspect of this. When you overlap many different waves of many different frequencies and wavelengths, the waves build up and cancel out in places in space and time so that you get one big lump in the center and everything canceling out every place else. That's another thing where possibilities of waveness produces particleness. It also works the other way around too. Well, this is just some of the ideas. Another aspect about this waviness part of it is that this waviness can spread throughout space and time. And when it does, it literally enables connections to be made which are not necessarily causal. They're maybe synchronistic. As Escher has done in this drawing, it's a winding which includes both of us in some particular kind of way. Now, I'd like to show you what this is called in physics non-locality. So I'd like to demonstrate with these cartoons how non-locality works in a physics experiment. You could think of this as a physics experiment being carried out with maybe a light source here and one photon going to this scientist and another photon going to this scientist, and they're looking in their devices to see what's happening. And it's a simultaneous event, bang and bang, happening simultaneously. It's interesting that I chose as my two examples to make the example dramatic, New York and Los Angeles. And what's really ironic about this is that as you'll see in a moment, I did this drawing approximately 2 weeks before the Los Angeles earthquake. Well, watch how I made the drawing. When the earthquake happened, I was literally shaken by this. So here's what happens. The observer in New York observes something here, which causes something to happen over here in Los Angeles instantaneously. It's not so much that he causes it, it's just that his active observation here and his active observation here are such that there's a connection between the two. It's not quite causative. The cartoon kind of like exaggerates the idea just a little bit, but it captures the spirit of what I'm speaking about. Well, let me now take you on a little more of a journey with me. I want to have us look at the nature of order, the nature of chaos, and the nature of what we mean by the world as we experience it. In what we might call the old physics, or the old way of seeing, or the old world, we all believe that the world was given and out there, independent of us. In the new physics, as I'm now bringing out through some of the things I'm sharing with you, we have the notion or the idea that the world is created as we enter into the problem. Okay? The big that it sort of isn't the problem that it's created or given. The big problem is one of control. How can we gain control in either of the two worlds? Okay? In the classical world, it seems to be maybe beyond our control, but yet something it's like a machine ticking off, and we sort of like watch it, but sometimes we could get control, but most of the time we have to sit and watch. In the quantum world, it might even be considered to be worse. The last drawing I just showed you was the idea of the universe being given by God to Adam, so I didn't comment on that because I sort of want to move a little bit faster. In the world we have of quantum physics, we say that the world is made of objects like billiard balls, okay? But when we look at these billiard balls, they pop and disappear. In fact, they pop again, and maybe they'll pop another time and sort of even change color on us, so that there's no absolute order to this universe. In fact, it's maybe even worse in quantum physics. We have the other notion that even time gets bent. We have another notion in quantum physics that these possibilities not only flow out into space, but they flow both forwards and backwards in time, which means that the future can influence the present, or the present can influence the past. So we have very new notions of the order of time and how time works when we take into consideration quantum mechanics. What I am implying here is that whatever order, however we want to try to control the universe, however we're going to do it, it probably is implying that somehow it's coming from our minds and our visions of how we exist in the universe. Einstein once thought that God does not play dice with the universe. He believed that there was a higher order to the universe and that somehow we didn't have the right equations to describe it. Looking at quantum phenomena is really looking at rules of a game and imagining how the game is played. It's a strange kind of a game. It's sort of like a chess game in which the pieces can disappear from time to time and change into other kinds of pieces, which of course that's what they do in chess. Like, for example, if you make a pawn get to the 8th rank, suddenly it's changed into a queen. If you didn't know that pawns could change into queens, you'd think, what the heck is going on here? This quantum rules or something like quantum probabilities can do something as strange as even that. So let me give you a very short picture of, again, how we see this. We see quantum waves, or we imagine quantum waves. We don't actually ever see them. We imagine that they look something like this. We imagine they're spreading out into space. And then we imagine that an observer enters the picture in some way. An act of observation occurs, and the wave suddenly starts going into collapse. And as a result of going into collapse, we have a particle which suddenly manifests into the physical universe. Again, it's choices that we make into how we look at the world which creates the world. So, if our choices, if what we choose to look at does affect the physical world, we might ask, well, what about the physical world that existed before there were human beings? How could human beings even arise in the physical world, and why are we here? What are they all about? Let's suggest a principle. It was first given by Brandon Carter. Later it's going to be talked to maybe, I think, by Frank Tipler, who will be here next season. It's called the cosmological anthropic principle, or the anthropic cosmological principle. I'm not sure which words come first. Namely, that the universe is here because we're here, or it's because that it was engendered so that life could be created. It's very hard to imagine a universe without a thinker or somebody inside to create or visualize the universe. Most of us, although, think of the universe in terms of, many scientists, in terms of sort of mechanical pictures, and think that somehow a thinker is nothing more than universal stuff in some kind of computer chip. Okay? But another vision is there might be some other spiritual presence which we might think of as a star child or universal mind, sort of like in Stanley Kubrick's movie 2001. This we might take as a new view. It's sort of bringing maybe a spiritual element back in the back door through the anthropic principle. Well, let's look at the anthropic principle very briefly. First of all, we're here. Now, where we are is not very maybe important seemingly to us as we look at our position in the galaxy. However, the key to recognizing something interesting about our position is the fact that it's just about right in order to have conscious beings and an environment and an atmosphere and etc. Not too close to the center where maybe there's a lot of black hole stuff going on, not too far away so that we're outside of any possible communications from other stars, which may be also important to us, that we'll learn about maybe later on in some new science. But yet just in the right position, just exactly the right size, planet, etc., in order for us to arise. For example, we've learned that life itself is a series of complex chemical reactions between elements such as carbon and hydrogen and oxygen and nitrogen and iron and potassium and sodium and many other elements. How do these elements ever even get created? If the forces of nature, which are dependent on certain constants like the charge of an electron or the mass of a proton, if they were changed by the slightest bit, none of the things that we see or enjoy as life could even be possible. Everything that exists was cooked or baked inside of stars. And if any of those forces of nature were out of balance in any way, if they did get out of balance, things would have either exploded or never have come into existence in the first place. So, everything was cooked inside of stars. Stellar alchemy, a magical brew. Hydrogen, which was the first atomic element that ever came into existence, according to the Big Bang Theory, had to come together, and there's some kind of way, which we're not clear really how stars ever form. We think gravitational attraction, but geez, to go from atomic hydrogen flying out into space into stars, I mean, you know, that's a big jump. I'm not sure we understand that very well. People say, oh yeah, that's what happened. Wait a minute, man. That's a pretty big jump. But somehow we think that happened, and that stars are perfect ovens for cooking hydrogen. They're just about the right size. There's radiation pushing the star apart. There's gravitational energy sucking the star in. And if the gravitational constant G were just a little bit weaker, the star would be a little bit wider. The temperature inside would be a little bit hotter. I understand it goes up as the thing expands. I'm not sure exactly why. You would think it would be higher if you go in, but it seems to cool when you do that. If I'm wrong about this, astrophysicists, correct me. I may have got this backwards, but I think I'm correct. At any rate, the temperature would not be the same if the radius had changed, if the gravitational constant were not the same, which would mean that it wouldn't be hot enough to cook or too hot to cook, which would mean that the elements would disassociate and it wouldn't be perfect as they are. So, G.K. Chesterton once said, taking into consideration all of the constants of nature that we have, and the speed of light being what it is, and the size of the universe being about 10 or 15 billion light years in diameter or width or whatever, however you want to imagine it, whatever shape it's actually in, G.K. Chesterton said, the cosmos is about the smallest hole a human being can hide his or her head in. So, putting our head in, we might wonder, could we get as lost as these creatures peering out into the universe? Well, maybe we would not get as lost as these creatures. The physical universe is certainly quite big, but the question is the physical world knowable? Well, let's talk a little bit about knowing. How do we know we know? Remember, I started off by saying one of the most remarkable things about being a human being is that you know that you know. So I think we now need to, in terms of looking at consciousness, we need to look at this thing called knowledge or knowing. Well, classical educational practice divides knowledge into two categories. One is called ontology, and the other is called epistemology. Now, the best I could say about these two is that ontology deals with the business of isness, and epistemology deals with how we know the business of isness. So in epistemology, we're dealing with what we know and how we know what we know. And in ontology, we're dealing with what's out there, so to speak. But in classical science, you might be able to make the division between how we know what we know and what's out there. But in quantum science, what's out there depends on what we know or think or envision is out there, and we seem to be affecting it. So in some sense, epistemology is affecting ontology, which in turn is feeding back and affecting epistemology, and there's some kind of circle going on here. Now, I would like to ask the noted expert, Humphrey Bogart, what do you think of my explanation of epistemology and ontology?
Everything's clear now.
Thank you, Humphrey. I hope it's as clear to you as it is to Humphrey. Anyway. No? Okay. So, what we're dealing with here is a sense of that in quantum physics, the separation between these two ways of dealing with experience, epistemology, ontology, are not as clearly separable anymore. There is no out there until there's a perception of an out there. So, what we see is created by our means of observation. And this is bizarre. So, why would God create a universe of matter in such a way that its ultimate nature is unknowable? I mean, in the sense of knowing exactly what's out there. Well, I'd like to suggest an answer to that question. It offers a lot of possibilities at one level for untold growth and possibly transformation and evolution. It also may be necessary in order that spirit become matter. That without this process of unknowability, there's no way that spirit could enter into the game. Or let's put it this way, it's maybe part of the sacrificial act of spirit to go into matter. God pouring God being into creation, and in so doing, forgetting, relatively going unconscious, and then undergoing a revolutionary and evolutionary process of creative reawakening. Well, perhaps that idea is just too much for us to grasp. So I'd like you now to relax a moment and listen as we take some time to hear the words of the Wizard of Oz.
You'd better close your eyes, my child, for a moment in order to be better in tune with the infinite.
So, let us close our eyes for a moment as we start to tune to the infinite and begin to inquire into the nature of the awakening. I'd like to suggest, as I'm going to talk now a little bit about my book, The Dreaming Universe, that as we awaken, the whole universe is created. That the awakening process is also simultaneously the process of creation of the universe. And that this notion is discussed, as I mentioned, in my latest book I call The Dreaming Universe. It was Schopenhauer who once put it the following way, and this will give you a hint as to the direction we're going as we begin to approach now, in the finale of this talk, the mind of God. Schopenhauer said, "The ultimate dreamer of this vast life dream is finally but one, and the multiplicity of appearances follows from the conditioning of the one by space and time. It is one great dream, dreamt by a single being, but in such a way that the dream characters also dream." So when we ask what is meant by the dreaming universe, we're going to approach it as if we are dream characters in someone else's dream. And now the question we want to find out is, can we catch the old one? Can we catch her dreaming? Can we find out how we, not only being dream characters, but can we awaken to the fact that we are the dreamer? What is dreaming? Why do we dream? What is the connection between our dreams and the dreams of others? I've spent some time looking at this question by talking to psychologists, talking to neurophysiologists. I've spoken to biologists. I've spoken to anthropologists. I've spent time with Russian political advisors in Moscow and St. Petersburg, talking about how dreams might affect culture. I've spoken with and spent time with Australian Aboriginals who taught me in the only way I could learn what dream time was about. And as a result of doing all this, I've come to a particular conclusion. And I'm going to share that conclusion with you. I should point out that dreaming is a controversial subject. And it has to be looked at carefully in the light of not only ancient theories of dreams, as presented by, say, such early Greek thinkers as Aristotle himself, but as well as modern experiments by Stanley Krippner and Monty Ullman when they were doing these experiments at Maimonides Institute in New York on dream telepathy, showing conclusively that during dreams, people can telepathically communicate with each other. That during a dream state, the dreamer is able to telepathically communicate. can actually pick up experiences and information. There is evidence that people can do this in so-called out-of-body experience. I'd like to suggest that the dreaming mind, not confined to the cubicle spaces of the everyday world, is free to enter into the blue spaces on the red background vision of a more spiritual, more intuitive, more freer space in which such things as this are possible. Okay? According to the ancient Aboriginals, or to the ancient Aboriginal concepts, there is something which is called dream time. And to them, dream time is far more important and real than what we call our real time. It's not that these people are stupid. It's not that they are highly emotional or highly irrational. They're extremely rational about this. They just sense that dream time is really the important time. And the dream time is not linear time. It's not the time of everyday experience. They know the difference between everyday experience and that. But it's a very important time. It's a time in which they can resonate. It's the time in which they sense their spiritual presence. What they truly sense is that there is a big dreamer, and that this big dreamer is dreamt everything into existence. And that according to this Aboriginal legend, the universe itself came into existence as the dream of a great spirit. And that the spirit is still dreaming, and that we are part of the dream, and that we can connect with the dream of the great spirit. And that is essentially what Aboriginal people are about. They are about connecting with the dream of the great spirit. They sense the dream of the great spirit when they walk the land. They see the land as sacred. They sense the dream of the great spirit when they hunt the turtle and kill the animal. They feel the spirit of the turtle and hope it enters their bodies. And they know what they have done. And they are thankful that the spirit has provided the turtle so that they can have sustenance. They sense the great spirit when they find the honey ant, which is a little tiny animal whose abdomen is so engorged with honey that they become literally snacks. They have honey ant dreaming. They have turtle dreaming. They have mountain dreaming. They have kangaroo and wallaby dreaming. This is all part of their spiritual heritage, of which they are eternally grateful, constantly reminding themselves through their songs and music that they are part of the Great Spirit. To them, we are nothing but dreams dreaming. We are the dreamer and the dream at the same time. That, by the way, if you are curious about that music, if you've never heard that before, that is called a didgeridoo. It is made from the trunk or a branch of a tree. I forgot which tree it is. Some of you out there may know. It's usually a dead tree, and it's hollowed out. There's a lot of dead branches on the grounds. If you spend time in the outback, as I have, you find it's a very fascinating place because it's usually very warm. I was there during the what we call their winter season, which would be equivalent to our summer season. But it was still pretty warm. Although it did get cold at night, and when I was camping out, I did have to have a blanket around me. I had marvelous dreams as I camped out under the Australian sky, and I could feel or sense the magic of the place. I mean, it's possible to escape because it's so vast and so flat, and you can see so far. It really is very thrilling to spend time doing that. It's understandable why they could see the world in terms of a dream dreaming. It's interesting that when I began to link together the various notions of dreaming, from whether it was anthropological or biological or whatever, I began to see that the basic thing which linked them all together was a science. I'm not saying this is the only way of looking at them, But a science that could link them all together, their different visions all together, their different ways of dealing with dreaming all together, was really something called quantum physics. And that there was a kind of a mechanics to this, which I might call quantum mechanics. So, the notion is that there's an unreality to things, that dreaming seems to involve both the process of envisioning or creating from superpositions of new visions or new elements, and that forgetting as well as remembering is taking place. This has been typified in the work of Francis Crick and also in some of the neural network models that Hopfield, J.J. Hopfield made from Caltech, indicating that we also dream to forget as well as dream to remember or reconstruct our existence. If we take both of these elements into account, both that we dream to forget and that we dream to remember, that dreaming takes both of these elements into account, it seems to me very similar to certain kinds of operations that we do in quantum mechanics. When we tend to observe things one way and repeat our observations over and again, we build up a consistent pattern of seeing that same observation over again. But if we look at the observation in a complementary way, we totally wipe out that pattern, and that will be equivalent to what we might call forgetting. So, forgetting and reawakening seems to be universal and part of the scheme, you might say, of not only human beings, but through quantum mechanics and its effect on nature, through the whole dreaming universe. The whole process of dreaming is often called Maya in many Eastern spiritual practices. So, taking this into consideration, looking at this for a moment as materialists, we might say the following. Okay, there is consciousness. I don't know what it is, but I know it exists. How does it arise? Looking at this materialistically, it arises from matter in complex interactions with itself. So that consciousness is an epiphenomena of dead inert matter arising in interactions with itself. Well, that's very fascinating if it's true. Taking that it's true, believing that it's true, then we also have the secondary hypothesis that since in consciousness dreaming takes place, then matter interacting with itself in some complex way is capable of dreaming. Matter dreams, ergo, for you materialists out there, the universe dreams. So, she dreams. But what does she dream about? Well, we can only guess about what the Great Spirit dreams about. According to ancient Indian myths, the Great Spirit dreams as the goddess Shiva. She is both the creator and the destroyer of worlds. Perhaps like the goddess Shiva, she dreamt of something called a black hole, through which time and space are created. She may have also dreamt of the complete annihilation of the world down the black hole drain. Well, do we believe this? Well, from a scientific point of view, it seems hard to believe that matter dreams. I mean, let's face it, it's a pretty far-out idea to any kind of rational way of thinking. Can I explain this in some scientific way? Well, let me say this. Based on as much scientific research as I could gather about the dreaming brain, I've come up with a model. We have our models! And the model indicates that there are certain kinds of correlations which arise in the dreaming brain. I call these quantum physical correlations. They are equivalent to what Jung called synchronicities. They're acausal, but they're linkages. So, taking that for granted, I will have to ask my world expert, Humphrey Bogart, based upon that notion of that matter can dream, may I ask you, Humphrey, what is matter?
The stuff that dreams are made of.
Thank you. So, according to the rules of quantum physics, as I've typified in this fractal diagram, which may or may not illustrate what's going on in the brain, there are connections occurring in the brain, in different parts of the brain, which somehow in just the fact that they're synchronistic and that they are causally correlated, quantum mechanically correlated, a sense of self is arising. And I think this is the key insight into what I am talking about. That it is possible that we can experience these connections, and if so, they will appear to us as synchronistic events of sense of self, and possibly, if we can experience these connections beyond our skins, as synchronistic connections as the magic we experience in the universe. It's like what happens when you fall in love. It's like what happens when you are inspired by a speaker. It's like what happens when you meet people, ha ha ha. Well, thank you. I mean, so it's what I would call synchronistic. And if I had more, maybe in a question and answer period or more time to spend with you, I could share with you some of the rather remarkable synchronicities that have occurred in my life and are continuing to occur in my life since I've devoted my life to bringing together the sacred and the scientific. It seems I'm on the right path for whatever reason, I don't know, but I think I do know, and I think it's an important part that this is a necessary work and a work that needs to be done at this time. These connections, I think, are synchronistic. Thank you. If you look at these connections from an outside point of view, from an objective point of view of looking at them, they seem to be very spontaneous and very chaotic, and it seems hard to believe that anything like a self can arise from them. So how does anything like a self arise from them? It's sort of like a picture coming out of the background. It's a merger of imagery. They occur during the phase of consciousness that we call sleep, more likely, more often than they do during wake. However, they are taking place all of the time, these kinds of connections, these synchronistic connections. You might say that this is reminiscent of what I might call the feminization of our brains, the synchronistic, acausal stuff of life that inspires us and makes us feel alive, that makes us feel that life is really worthwhile. Let's face it, causality in mechanics is wonderful for figuring out how things tick. But you know something? On the level of evolution, it's a pretty low rung. Basically, cause and effect relationships may be important for survival, but it's basically pretty much the way the reptilian brain operates. So, I mean, any computer machine computer machines today can recognize objects out there, and they can say, that is a cube, pick it up with the hand in shape of cube. That is a sphere, pick it up. Any computer can do that. It's very cause and effect, very mechanical, But the computer can't recognize that it's beautiful. And it would be very confusing if it was a quantum object that changed from cube to sphere. It wouldn't know how to deal with it. So what we're dealing with now is looking at the brain, looking at the mind and the brain, of how the self arises. And I'm saying now that it's very important that we consider this as arising during a process that we would call sleep. So the events are random. Even though they are random, and there's no way to predict just how or when these awareness events are going to occur during dreams, the fact that they are connected is what gives a sense of order, a sense of wholeness. And it also, I believe, initiates the process by which we as beings become aware of ourselves as beings. It's the initiatory process by which we say to ourselves, I know that I know. There is in my book an attempt to explain how that happens, and it even shows how certain kinds of devices that can exist at the neural level can begin to process imagery in such a way that they contain information about themselves that if they give out to other neurons will disrupt themselves, but if they hold the information in, will contain their information in such a way that there is a division between them and the outside world. In other words, it may be that spatial boundaries are occurring through this process of image recognition. It's more complicated than I can explain in a short time. I'm only giving the highlights of it. If that's confusing, I hope you forgive me for that, but I cannot get into it much deeper than that at this point. Well, since I can't get it any deeper, am I overstepping my bounds talking about such metaphysical issues such as science and spirit being reconciled? Okay, Einstein certainly must have done this how many times? Einstein always felt he was a pretty ordinary fellow and wondered what all the fuss was all about. Did you know that Einstein came up with the greatest theories in 1905 when he was married to a woman who was also a physicist, and that when he got the Nobel, when he wrote to her when he was separated from her for periods of time, when he was doing some research someplace else, he said, I hope people will understand our theory of relativity. Did you know that? Did you know that when Einstein, after he divorced his wife in 1920 and got the Nobel Prize, that he gave her all of the Nobel Prize money that he received? All of it? Did you know that? Did you know that after his marriage to this remarkable woman who has been left in, obscurity, that there's also there's some very sad stories here about her. She was really an interesting woman. That after let's see if I can recall. I told you about the money situation. I've forgotten what I was going to say next, so it'll come back to me. I want to tell you something a little bit more about her. Yes, I remember now. The most remarkable thing that happened to her was that she was as smart as Albert was, but because she was a woman, she was not allowed to go on to the PhD level or get her PhD even after doing her thesis because they considered her grade level too low. She had something like a 78 or an 80, whereas Einstein's was not much higher than that. Think about that for a moment. Anyway, Einstein dealt with metaphysical issues, so why can't we all? How does a quantum physicist compare with a guru? Well, they represent a kind of an odd couple. Gurus look inward, quantum physicists look outward at the universe. So, in a certain sense, we need to be able to compare the two to bring the outward and the inward looking together. If you've understood some of what I said, you recognize that the looking outward doesn't just take place by itself. You have to look inward to come up with a model of how to look outward. So in a certain sense, there is a bridge between the two. They're not so odd after all. As Jesus and Buddha taught, do physicists of today teach principles that can transform our lives? Well, I think that they do. I think that there is new metaphysical principles that can be taught. And I think one of the most important ones is the notion that observation affects, changes, alters, and creates reality. And I think that's something we need to look at in the bridging of the gap between spirituality and science. Is there a physics of the spirit emerging in our materialistic culture? If I'm part of it, there is. And I hope that it'll continue to grow as more and more people come into science, demanding that the sacred be investigated and not letting it die or go to the wayside. So I do think the answer is yes, but I think that a marriage between the two, between the rationalistic right side and which is, I guess, your left side, and the spiritual other side, that these two are going to have to come together to form some kind of union in maybe some kind of new space, and that I think that they can do it and that it will take place. but they each are going to have to take different perspectives on what each is doing. When they do merge, how will the practice of religion, or how will that change? Well, we're looking at now bringing together the knowledge of DNA with the knowledge of a spiritual practice. And I believe that it can change, and that it would lead to a new worldview. But in order to do so, we have to give up our divisiveness in terms of the mandatory need to say that the creationists are wrong and the evolutionists are right, and the evolutionists are wrong and the creationists are right, and begin to see how they're really saying the same thing. Both are myths created by human minds, whether we think they're God-given or not. They are still basically things we think. And so the scientific myth really is no stronger in the overall picture of the universe than the creation myth. They're equally valid ways of seeing. Well, interesting that some people feel that way. I don't know who I'm talking to out there, but that's very, very interesting. Can quantum physics help us to a complete revolution of our fundamental institutions? Well, I think it can, but I do think we need some spiritual practice in there somewhere. I do think that we have to begin to look at things in a different way, that we have to maybe inquire into the surreal or the magical order of the universe, and that is a very important thing that has to be done. Maybe we need something like parallel universes to look at. So, to really grasp this, maybe we have to begin to give up the notion that everything has to be solid and material and out there in order to be real. And we need to look at time in a different way. I've already suggested that time might be a loop, and if so, we might want to look at some of the kinds of questions that people that are interested in spirituality often ask. One of them has to do with reincarnation. Can we find a scientific basis for it? Well, I think we can. I think that we can begin to inquire into the nature of our soul and maybe find as much evidence for the soul as we have found for the electron. Think about what I'm saying. I'm not putting the soul down or building the electron up. I'm saying, really, think about it. That these are, from a certain from a human point of view, without going off into either science or spirituality, they're conceptual concepts. And yet, they're very meaningful to us in certain ways. So if we are going to deal with questions of the soul, then we should look at certain frameworks. Let's look at a certain time framework. What happens when we die? Does the soul continue? Is there something which continues? I'd like to say that the answer is yes. That from my scientific mind point of view, from what I've looked at and what I've experienced by exploring both the rational and the spiritual, the mystical and the logical sides of myself, that there is something which survives, and I can almost give you a proof of it tonight. That you can have an experience of it, I believe, that will convince you that there is something which is going to survive your death. And I'll try to share that with you. I hope maybe one of you will ask me to do that in the question and answer period, because I have to get moving and get to the conclusion, because I know I've been keeping you overly long. So let's ask about what happens when you die. What happens when you go through the portal of death? Do we possibly go forwards in time to some new life? Well, if time is a loop or a circle, maybe we can reincarnate in the past. Ancient days of Rome. Or maybe we could reincarnate on another universe, another world, a parallel world where we can have romantic adventures. Why not? Those of you that like Egypt, come on back with us. We love Egypt. Go back to the boy king, Tutankhamun, and see what's in store there. Maybe become him for a while. Rebirth is possible so long as we don't think of time as being linear and a straight line. And I've already indicated to you that tribal people don't necessarily think of time that way. Although the notion of time being a straight line has been basically refuted by quantum science, And even the notion that there's only a now and that the past and the future really don't exist. The past is gone and will never come back. The future is yet to be and don't exist. There's only the now. There's a very simple experiment we can do right now to prove that that's wrong. That the past, the present, and the future exist right now. Would you like to do that experiment together? All right, it's very simple. Just follow me on this, okay? It's simple. Do, re, mi, fa, sol, la, ti, do. Now, you know what I sang, right? Not very well, but you certainly heard it. If there was only a now, you would have heard only the do. You'd have no idea of the re, no idea of the mi, but your mind put together a melody of the scale going up. Some of you may have heard the whole thing at once, or some of you may have heard the do-re-mi relationship. When you listen to a symphony playing, you don't just hear one note at a time, you hear the blending of several notes. Well, some of those notes are in the past, some of those notes are in the future, some of those notes are in the present, and yet you hear the whole thing together. When you change your mind's eye and focus in on only the notes, single at a time, you may just hear single notes, but then you miss the symphony. This is indicative that we can change the time window. In other words, it's not true that there's only a now. There is always present, a past, a present, and a future. Right? You agree with that? Think about it. Music is a very simple way to get out of time. I mean, really. So, the notion of time being linear is basically refuted by our own common sense, common experience. It's also refuted by 20th century physics. Einstein already refuted the notion that there's only the time now, that there's, by his notions of simultaneity, that both the past, the present, and the future could be existing all in some sort of omni-now. And we now see in quantum physics that time does run in a circle. We have time loops. There's a certain interpretation which says that the past can send a quantum wave into the future, and it can resonate and send a quantum wave back into the past, so that there's a kind of a overall resonant experience here. Quantum mechanics indicates that there are subatomic processes that involve communications from both the future to the present and from the present to the past. Now, I'd like you to consider something with me, and we're just about to conclude, so hang in there for a minute longer. I'm sorry I'm keeping you so long. I hope that the experience is worth your time. Thank you. In the March issue of Scientific American, David Deutsch and Michael Lockwood discussed the possibility of not only time loops, but of time travel. I believe that time travel is something that some of us are going to experience within the next 20 years. That it's real, that we'll be able to do it. And that we're already beginning to learn something about the physics of it so we can believe it's possible. Problem with us is we don't believe things because we think the laws of physics say that they're not possible. What I want to tell you right now is there's nothing in the laws of physics that prevents time travel. I'll repeat it. There's nothing in the laws of physics which prevents time travel. I want to explain that to you. The first thing I want to do by explaining that to you is to point out an aspect about time travel which most people think defeats the possibility of time travel. And that's this notion. It is now today. Sitting over here is a time machine. It has a door. You may enter the door today, or you may enter the door tomorrow. Suppose you decide to enter the time machine tomorrow, go backwards in time one day to today, and come out of the time machine at exactly 1 minute before now, or 1 minute after now that you're thinking about. Let's say 1 minute after now that you're thinking about this. So 1 minute from now, you decide the following. If I come out of that door while I'm standing here, okay, so that there's two of us here, then I will not enter the time machine tomorrow. Which means that I can't come out the door today. So if I come out the door today, then I will not enter the time machine tomorrow. Therefore, since that's obviously a reductio ad absurdum, time travel is impossible. Typical argument. Now, would you like to see the solution to that problem? Would you like to see how you can not only enter the time machine tomorrow, but you can also decide not to enter the time machine tomorrow at the same time? You want to see how that works? Here it is. You have to live in parallel universes. That's all that it takes. Now you might say, parallel universes? Come on, Dr. Wolf. What are your parallel universes? Well, I did write a book about them. It's called Parallel Universes, and it does indicate solutions to this problem, and it also indicates why physicists believe that parallel universes may really exist, that it's not just an imaginative exercise, even though they may seem to be superfluous or so abundant as to make it ridiculous, or, my God, how can we keep track of all that stuff? Nevertheless, let's look at how it resolves the time travel paradox. Here we are in what is called B universe, and here we are marching along. Here's today, and we wait till tomorrow, and we enter the time machine tomorrow. We go backwards in time along a time loop, but we don't come back today into this universe. We come back today into the A universe here. And now we emerge in the A universe. Here we are, walking along. See, there's parallel us's. This is me, this is me, this is me, this is me. We're all in parallel universes, that's all. And here I come back out, and I join up with myself. I say, hi, Fred, how are you? And my Fred says, hi, Fred, how are you? Gosh, it's nice having a twin for a change. And the two of us go off together in universe A, happily ever after. In universe B, we disappear. And there's an infinite number of these universes in which all this can happen. It's perfectly consistent. If it's not me, we could do that with particles. In other words, it's perfectly consistent that particles could disappear from one universe and reappear in another universe. So, this may have something to do maybe with the cold fusion problem. I don't know. Maybe this is where energy is coming from, something from nothing. You know, we need to entertain ideas like this, because sometimes they actually lead to something that can be tested experimentally. Okay. We've reached